There are two ways that we can form ether channel bundles. We can form them dynamically using protocols, or we can form them statically by manually entering the commands that are necessary to form the ether channel bundles. However, I am steering you towards the dynamic option for your ether channel bundle formation. And the reason why I'm steering you that way is because the protocols are designed to ensure that if any issues happen or misconfigurations happen, a layer 2 loop will be prevented from occurring within the layer 2 infrastructure where the ether channel bundle exists. The last thing you want is to statically set up your ether channel bundle and either misconfigure it or have a failure that occurs, and then there is a loop because spanning tree protocol fails to recognize the problem because of the ether channel bundle that it still sees even though there's an issue. So the dynamic approach, we have two different options inside that approach. Number one is LACP, Link Aggregation Control Protocol. This is an IEEE standard, and since it's an IEEE standard, you can utilize it between Cisco products, or you can utilize it between a Cisco product and a product from another vendor. PAgP, Port Aggregation Protocol, is Cisco's proprietary ether channel protocol, so it's only usable between Cisco switches. What's the difference between the two? Well, they're very, very similar. They're very, very similar. For example, they both support only 8 active links. And typically when we form ether channel bundles, we will either put them in pairs of 2, 4, or 8. Powers of 2. 2, 4, or 8. And this is the same for LACP or PAgP. Now what happens if a link fails? When we have 8 active links? Well, if one link fails, we have 7 left over. What if 2 links fail? We have 6 left over. We have to manually intervene at this point and replace the links or fix the problem. However, with LACP, we can have up to 16 links. But remember, only 8 are going to be active. What does this provide for us? Well, it provides us a higher level of availability. Why? Well, if we have 16 links in a bundle and 8 are active, 8 are standby, then if one link fails, one of the standby links goes active. We still have 8. We haven't had to manually intervene yet. 2 links fail, not a problem. 2 links go from being standby to active. Now we have 8 links still active. So we have this higher level of availability with LACP than we could achieve with PAgP.